know what a sliding rule is for. But I do know what it was too. Smart to be with you. What a wonderful world this would be.
Good afternoon, everybody. Welcome back to Mr. K's 30 Minutes of Math. I hope you're all having a great day. It is beautiful outside. The sun is shining. It's nice and warm. So I hope you got a chance to spend a little bit of time outside, whether that's for your PE time or just to enjoy the beautiful weather. Well, let us get started. We are going to jump right into our riddle from yesterday, and I'm curious if anybody was able to solve it. It's kind of a tricky one, and it took lots of folks that I have shared it with a number of times to try to figure out. So let's dive right in. So you have these pennies in a pyramid, or a triangle rather, to be precise. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pennies. And the trick here is, can you move just 3 of them to flip this triangle upside down? Can you move 3 pennies and flip the triangle upside down? So I know when I first tried this, it was a struggle. I moved this one over here and tried that. So then that would get rid of that guy. And then I thought maybe I can move this guy up here, and that would get rid of that guy. But then kind of got stuck. But then I realized, aha, I could move this one over here, and that would get rid of that guy. And then look at that, we have the triangle upside down. So try that out with any friends or family. It's a pretty cool riddle, easy to do with just pen and paper, or if you actually have the pennies, that can also be fun too. All right, I am going to get started. We have our homework from last night, comparing each of our fractions, greater than, less than, or equal to. I'm just gonna work on a couple of them today. Let's see, let's start with the first one, 1/7 and 2/7. Well, this should be by now obvious to you. If we have 1/7 on one side, 2/7 on the other side, well, 1/7 is definitely going to be less than 2/7. Let's go over to B, 5/7 versus 11/14. Well, we can approach this lots of different ways. I think the easiest would be to go from 5/7 and turn that into 14ths. And we know how to do that. That is, in essence, decomposing our 7ths into 14ths. We would do that by multiplying by 2, and that would give us 10/14ths. So if we had 10/14ths versus 11/14ths, well, we know 10/14ths is less than 11/14ths. Let's do a couple more. C, we have 7/10 versus 3/5, and this time we're going to decompose tenths into fifths, and so 7/10, we're gonna turn them into fifths. Now we're gonna divide because we're decomposing. 10 divided by 2 is 5, and 7 divided by 2 is 3.5, or 3.5 fifths. Well, 3.5 fifths is definitely more than 3/5. All right, let me just do one more. We'll do D, 2/3 versus 9/15. Well, on this one, we can go from thirds to 15ths. So we're going to decompose our thirds into 15ths, which means we're going to multiply. 3 times 5 gives us 15. So 2/3 is the same as 10/15, and we know that 10/15 is definitely more than 9/15. All right, fantastic. Real quick, if you were able to do the rest here, we see 3/4 and 9/12. 3/4 is the same as 9/12. Prove that one. Well, we're going from fourths to twelfths. We're going to decompose fourths into twelfths. multiply by 3, multiply by 3. So these are equal. Last one, 5/3 versus 5/2. Well, 5/3 is the same as 3/3 and 2/3, or 1 and 2/3. 5/2 is the same as 2/2 plus 2/2 plus 1/2. So that would be 2.5. 1/3 versus 2.5. 2.5 definitely wins, and there you go. All right, that was quick, but just wanted to go over the homework. Let's jump to what we have here today. Adding and subtracting, very exciting. We have done understanding fractions, decomposing, composing, ordering fractions, and now we're going to jump into adding and subtracting fractions. And to start off, we're just going to use some words. So I'd like everyone to go ahead and take a minute and do A, B, C, and D, and we will be right back. I'll give you a little bit of music as you are working on those. Okay, welcome back, welcome back. So let's see what we have here. I would love to know if anybody could tell us, what did you get for A? 3/5 minus 1/5. If you'd like to write in, that would be fantastic. 3/5 minus 1/5. Go ahead and write in. And we have a few folks chiming in already. We have from Lil Tank and from Ezra 2/5, and that is exactly right. 3/5 minus 1/5. If you've got 3, you take 1 away, you've got 2/5. The word fifth shouldn't make you think any differently. It's just like saying if I had 3 apples, those aren't the best looking apples, right? But I'll try it. And you took away 1 apple, then you're gonna have 2 apples. Same thing, you have 3/5, you take away 1, you've got 2 left over. All right, fantastic. Let's go ahead, B, 5/5 versus 3/5. What are we gonna get? 5/5 versus minus 3/5, my apologies. You guys got it, 2/5 again, very similar. We have 5, we take 3 away, we've got 2 left over. 3/2 minus 2/2. What do I get? 3/2 minus 2/2. We got folks writing in 1/2. Very good. 1/2. Very good. That's right. You had 3, you took 2 away. And last, 6/4 minus 3/4. You have 6, you take 3 away. How many fourths do we have left over? Excellent. 3/4. This is proving to be very simple for you guys. I love it. So let's move on. Now we're going to add and subtract, and we're going to use number bonds to convert from, excuse me, to convert to a mixed number. So you'll see we start off here, and let me highlight a few things for you. We have 12/8 minus 3/8 equals 9/8, and then the 9/8 has been shown as a number bond of 8/8 and 1/8. And we know 8/8 is 1 whole, so that's how you get the 1 whole. And then we have 1/8 left over, that goes right there. So let me do B, and then I'm gonna have you guys do a few. So 12/6 minus 5/6. Well, if we have 12 and we get rid of 5 of them, then we should have 7/6 left over. Now let's do our number bond. We have 6 sixths and 1 sixth. We know that is 1 whole. So we have 1 and what's left over? 1 sixth. All right, let's do one more and then I'll have you guys do them. 9 fifths minus 3 fifths. Again, you guys know this. You've got nine of these things. They're called fifths. We take 3 of them away. What are we left with? 6 of them. There you go. And let's do our number bond. How many fifths make a whole? Easy peasy, 5 fifths. And then you have 1 left over. That gives you 1. And then you have 1 fifth left over. Okay, go ahead, do D, E, and F for me. And I will be right back. All right, welcome back, everybody. I hope those went well. Let's take a look. Starting with D, I think I'm gonna go with blue now. 14 eighths minus 3 eighths. I would love to know what folks got as your answer. So go ahead and write in 14 eighths minus 3 eighths. Little tank, 1 and 3 eighths. Anybody else wanna chime in? We'll see. Let's do this one. 14 eighths minus 3 eighths. We have 14. We take 3 away. I see Ezra chimed in, 1 and 3 eighths as well. So we'd have 11 eighths. Then we can do our number bond, 8 eighths. And how many are left over? 3 of them. And we know that's 1 whole. So 1 and 3 eighths. Beautiful. How about E? 8 fourths minus 2 fourths. Ooh, little tank is already jumping ahead. 1 and 2 fourths, let's see. 8 fourths, we take 2 away. You've got 6 fourths. I'm gonna actually draw that up here so we have more room. Then do our number bond. 4 fourths is 1 whole, and we have 2 fourths left over. That's 1 whole and 2 fourths. Well done, everybody. And last one, F, 15 tenths minus 3 tenths. Oh, 1 and 2 tenths. You guys are rock stars, rock stars, rock stars. Thank you so much. Well done. Okay, ready for our math joke of the day, everybody. Why shouldn't you mention the number 288? Why shouldn't you mention the number 288? I'll give you a little Jeopardy music to think about that one, and we'll be right back. Okay, welcome back, everybody. Anybody have any ideas? Why shouldn't you mention the number 288? Anybody want to try, I guess? All right, I don't see any guesses, so let's do our drum roll. Here it is. Because it's too gross. Now, if you're scratching your head and that doesn't quite make sense to you, well, let me explain. This phrase, too gross, is sounds similar to too gross. Now, you might be asking, what is a gross? Well, a gross is 144. 144. So too gross would be 288. Sounds similar to too gross, T-O-O, which would be like very gross. So that is our joke for the day. But it started me thinking about lots of different words which stand for numbers. By the way, before I tell you about more of those words, 144, I have a question. What is the square root of 144? Remember square roots? Oh my gosh, you guys are amazing. That is very, very good. Do you remember what the square root of 169 is? Let's see if you guys can chime in. Oh my, you guys are rock stars. Fantastic. All right, so it started me thinking, as I said, about other words that stand for numbers. So let me just show a few of them. So you probably know a dozen, which is, of course, 12, like a dozen eggs. We just talked about gross. Here's score. Score is 20. Grand, 1,000. Now, I know the word myriad. I always thought it just meant a lot, but they have it here as 10,000. And then there's the word Google. I'm going to say more about that, which is 10 to the 100th power. So that is 10 times 10 times 10 times 10, 100 times. And then a Googleplex is this monster number. It's 10 times itself a Google number of times, which is just a ridiculously large number, which is hard to even think about. But as I was doing this research, one of the things that jumped out at me was score. So there's a famous speech by President Abraham Lincoln. It's called the Gettysburg Address, the Gettysburg Address. And he gave this speech in 1863, right after the Battle of Gettysburg, which was one of the toughest battles of the entire Civil War. Many, many people were killed during the Battle of Gettysburg in Pennsylvania. And he gave this speech. This is the whole speech. It's a very short speech, but it's very famous because of the impact that it had during the war. And he gave it at the dedication of the cemetery, the National Cemetery, for everyone who had died during the battle. And you can still go visit it in Pennsylvania after all this crazy coronavirus stuff moves on. And why it stuck out to me is, oh, I'm glad to see some folks read about this in class. The very first line of the speech, which you may have heard before, goes like this. I put it in red. 77 years ago, our fathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men, I would say all people, are created equal. So my question is, how much is 77 years? 77 years ago. Please tell me, take a second, think about that. How much is that? 77 years. 77 years. Ezra chimed in with 87. Anybody else? Agree, disagree? 77 years ago. Well, let's look. A score is 20. So 4 times 20 equals 80. And 7. So we'll add 7. That gets us to 87. That makes sense. 4 times 20, and then we're going to add 7, so it takes us to 87. So my question is, if this speech was given in 1863, And he says, 77 years ago, our fathers brought forth on this continent a new nation. What year is he talking about? It's 1863 when he gave the speech, and he's talking about 77 years ago. I want you to try to figure out what year is he talking about. I'm going to give you a little Jeopardy music on that one as you think through it. Here we go. I think the music's coming. Let's try now. All right, so a number of you write in 1776. That is exactly right. And I'll do it up here, 1863 minus 87. As you're saying ago, that means in the past. I will do this quickly. So we are going to borrow 10 from this 6 right here, which is going to turn that 3 into 13. 13 minus 7 is 6. We can't do 5 tens minus 8 tens, so I'm going to borrow from this 800s and make that 15 tens minus 8 tens gives us 7. Then we have 700s and we have 1,000, and there you have it, 1776, which you should all know is the year America was founded. Pretty cool, I think. One more thing I wanted to show you about words that go with numbers, and I'm seeing that my screen is no longer sharing because I'm trying to move it. So hold on one second. I'm gonna share it again. Hold on, we'll get this all figured out. And you know what, I'm gonna stop. There it is, voila. Okay, so you have all heard of and used the web search, Google, right? Everybody talks about it, just Google it, as folks say now. And if you notice, Google is spelled, whoa, that's not what I wanted. Google when you go to the search engine. But the math term Google is spelled Googol. And so I looked this up and found that the people who created Google, and their names are Larry Page and Sergey Brin, when they were trying to think up the name for their search engine, which was becoming a new company, they originally thought of the term Google because it refers to such a large number. Now, one of their friends who was with them at the time made a spelling mistake when he searched to see if anybody else had a company named Google.com, and he typed in Google.com, and they found that that was available, and one of the founders, Larry Page, liked the name, and within hours he took the step of registering the name Google.com for himself and Sergey Brin. The domain name registration records dates from September 15th, 1997. So there you have it. You can tell all your friends about where the spelling of the Google search engine came from. All right, let's get back to our lesson just a little bit more before we wrap up for the day. Adding and subtracting, real quick, I'd love to see from folks 7/4 minus 5/4. Go ahead, type in your answer. 7/4 minus 5/4. We've got some of them. We get rid of 5 of them, and we end up with how many? 2/4. Ah, yes, that is the same as 1/2. I want to show you this on a number line, though, so we can use it for more advance things later, we're talking about fourths. So I want to make sure that I have fourths. That would be 0 fourths, 1 fourth, 2 fourths, 3 fourths. 1 would be 4 fourths. And then I would have 5 fourths, 6 fourths, 7, whoa, that's not right, 7 fourths, and then 2 would be 8 fourths. So if I started at 7 fourths and I took away 5 fourths, do I go left or right on the number line? I'm taking away 5 fourths, so do I want to go left or right on the number line? What do you guys think? I have 7 fourths, that's where I'm starting, and I'm taking away 5 fourths. Should I go left or right on the number line? Which way do I go? Left or right? I'm starting with 7 fourths. Well, I'm gonna go left because I wanna go lower. So I'm gonna take away 5 fourths. Let's do it. 1, 2, 3, 4, 5 fourths, which takes me to 2 fourths. And there you have it, 2 fourths. Now, we can also do this with addition. So here you go. Just like we set it up. You know what? I don't even need to draw a number line again because we already have fourths. So this time I'm going to use green. We started at 5 fourths. And we're adding 2 fourths. We're adding. So adding, you're going to go to the right because you want it to get bigger. 1, 2. And so we are back at 7 fourths. All right. We have a little bit more time. Let me just check. Here's what I'd like you to do. I'm going to do these with you. 16 ninths minus 5 ninths, and we're going to use a number bond to decompose the difference. So 16 ninths minus 5 ninths, that will leave us with 11 ninths. What is 11 ninths decomposed with a number bond to show the difference? We have 11 ninths. How would I decompose it? We'd have 9 ninths and 2 ninths. There you go. Very good. Lots of folks writing in. 9 ninths equals 1 whole, and then we're going to have 2 ninths left over. Very good. And how about number 2? 5 twelfths plus 10 twelfths. What would that give us? And then use a number bond to decompose. So tell me, what would 5 twelfths plus 10 twelfths be with a mixed number? Well, if we have 5 twelfths and we add 10 more twelfths, we're going to wind up with 15 twelfths. We decompose that with a number bond. We'll have 12 twelfths. Well, that's 1 whole. And we'll have 3 twelfths left over. So there you have it, 1 and 3 twelfths. All right, very good. You guys have got this rocking and rolling. Here is, I'm going to give this, actually this as your homework. Go ahead, take a picture or a screenshot. You're going to add these up, use a number bond to decompose the sum, and record your final answer as a mixed number, just like we were doing. So 3 fourths plus 3 fourths would give you, whoops, my apologies, 6 fourths. We'll decompose that, 4 fourths and 2 fourths. And we know 4 fourths is 1 whole, and then we have 2 fourths left over. You're going to do the rest for homework. Before we go, though, let's look at our riddle for tonight. Here it is. You have basically like a grid made up of matchsticks. So each of those is matchsticks. You can pretend that they had like the little part on the end that you strike to make the flame if you'd like. And the trick is, can you move just 2 of the matchsticks? Oh, not matchsticks, they're toothpicks. My apologies. Can you move just 2 of the toothpicks and create 7 squares? So you can only move 2 matchsticks. You can move them anywhere you want, and you need to create 7 total squares. Go ahead and work on that tonight, and I will see you back here tomorrow. Thanks everybody for joining, and have a wonderful evening. Bye-bye, everybody.